yesterday we talked about finding a bunch of different things in order to sketch a curve, and one thing I mentioned was an oblique asymptote, but I didn't tell you how to find it. That's what we're going to learn about today. So, oblique asymptotes are diagonal asymptotes. So if you look here, we've got one vertical asymptote, and then we have a diagonal asymptote, which is our oblique. So, how do I know when I have an oblique asymptote? Oblique asymptotes occur in a rational function, which is a fraction, when the degree of the numerator is higher than the degree of the denominator. How do we find them? Oh no, we must do long division. So, let's look at this first example. It says find the oblique asymptote. So, 2x squared minus 5x plus 5 divided by x minus 2. Ask yourself, x times what will give you this 2x squared? And it's 2x. Put it above the 5x because it's to the first power, and so is the 5x. We kind of keep columns based on their powers of x's. Distribute the 2x to the x minus 2 out front. So we get 2x squared minus 4x. Subtracting is really adding the opposite. So we're going to make the opposite and then add to get negative x plus 5. X times what will give us this x times what will give us this negative x? Well, negative 1. Distribute the negative 1 to the divisor out front. We get negative x plus 2. And we need to make it the opposite, and we get 3. Now, our oblique asymptote is the equation of the dividend, the equation of the quotient without the remainder. So we have to ignore the remainder. So our oblique asymptote would be y equals 2x minus 1. That line is our oblique asymptote. Let's try one. Find the oblique asymptotes for the following function. Oh, I think that's what we just did. Yes, we already did that. So, moving on, determine all of the asymptotes for the following functions. Well, vertical asymptotes are easy. X equals 2, it's where the denominator equals 0. Horizontal asymptotes, we need to do the limit. At positive and negative infinity, I'm going to divide by x, because we divide by the highest power of x in the denominator. We end up with, when we plug in infinity or negative infinity, well, let's reduce first. So let's keep our limit. We get x minus 1 plus 4 over x, and at the bottom, 1 minus 2 over x. When we plug in our infinity, we're going to get infinity. And when we plug in negative infinity, we also get infinity. So there are no horizontal asymptotes. For our oblique asymptote, we're going to have to use long division. So I'm going to switch colors because I'm kind of running into my work above. We get an x, distribute the x. Find the opposite. So our oblique is y equals x plus 1. Be our oblique asymptote on that first example. Now, go ahead and try example 2 on your own. Find all the vertical, all the horizontal, all the oblique, and we will talk about it in class tomorrow.